Corporate Finance Excel Practice Problem, Present Value of an Annuity. Don't leave profits solely to chance. Instead, use Corporate Finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and are following along, note we are in the Practice tab. The other tab will basically be the answer key to it, so you can check out how it is formatted there as well. We're going to have our information up top on the left. We're going to do the calculation a couple different ways. One, we're going to do the calculation with a mathematical formula. We'll then break the annuity down to present value of one calculations, basically doing a running balance calculation in Excel. We'll also take a look at it in terms of an Excel formula, and then we will use the tables for the same calculation. This will be very useful once things become a little bit more complex rather than have a standard type of annuity. So it's useful to know these different ways to calculate something. If you only have one way of calculating it, you're probably not fully understanding it. And if you're in other situations or things become more complex, you might not fully understand what's going on and be able to push forward with it. So we have the present value of an annuity received per year, 40,000. The years are going to be 14. The percent is going to be 14%. Now you might see this presented in some like a prize type of situation. For example, if I was to multiply this out, if someone was going to receive 40,000 times 14 years, they would be getting 560,000. So you might see kind of a false advertisement type of situation where it says basically someone won 560,000, but you look at the details, you look at the fine print, they're going to get paid that 560,000 over 14 years, which decreases the value really of it. So then you want to think, well, what would it be in today's dollars, that type of situation? To do that, you have to figure out what the discount rate would be, which is not the easiest thing because once again, there could be multiple factors, inflation, and you could think of the opportunity cost of the money that if you had it today and so on. So once we come up with that discount rate, then we can do our present value calculation. Because this is a standard amount of payments, rather than using the present value of one, we can simply use the annuity calculation. So we can do that a few different ways. We'll start off with the formula, which is the formula down below here. Now I'm going to break this formula out into a table type of format. And so we'll break it out into kind of like what you might see in a tax return or something, line by line. To do this, I want in the outer column, basically the P times this whole thing. And then in the inner column, I'll have the numerator and denominator here. And then I want to have any more detail I need in the inner column here as well. So let's take a look at it. I'm going to start off with the payments that we're saying are going to be the 40,000. I'll put that in the outer column because it's going to be this times this. And then inside, I'm going to start to construct this numerator, which is quite long. I'm going to put the 1 in an outer column here. And then we'll come back to that later. And then I'm going to take the 1 plus r to the negative n, this component of the equation. I'll break that out step by step here. So I'm going to say 1 plus r, which is going to be the 14%. Percentifying that, home tab numbers percentified, underline, home tab font, underline, and then summing it up with the trusty equals sum function, adding it up. Going to percentify this cell now. Home tab numbers percentify, 114%. Now we're going to take it to the power of n, which is going to be the number of periods is 14, and it needs to be a negative, so I'm going to make it a negative 14. So to the power of n. I'm going to pull this out into the outer column so that I can subtract this numerator now from the 1 I have up top here, so that'll finish up the numerator. So I'm going to say this is going to be the 114% times, or not times, to the power of shift 6 or the caret, this 14, negative 14. And then let's add some decimals. Home tab numbers, decimalize it there, which isn't really a word, but I kind of like the sound of it. And then I'm going to underline here, home tab, font group, and underline. And there we have that. Let's underline here, home tab, font group, and underline. Then we'll do the subtraction. So 1 minus this entire thing, subtracting this out now. So the 1 minus that big thing. And then we'll add decimals, home tab, numbers, decimalize it, adding decimals so it's a little bit more that we can see. And then we've done the whole numerator. Now I'm going to bring the denominator into the cell here. So here's the numerator now that we've now broken out. Denominator is going to be equal to that 14%. Then we'll percentify it. Home tab, number, percentify, underline it. Home tab, font, underline it. And so now we have the numerator and the denominator. Let's go ahead and do what we do when we have those two numbers on the top and the bottom. We take the top one and divide it by the bottom one. And then I'm going to go to the home tab, number, and add some decimals there. So we'll add a few decimals there. And then underline, home tab, font group, and underline. Now we've got P and this whole thing. So there's P and there's that whole thing, which is represented by that one number, which we can now multiply out. So I'm going to say this is going to be the 40,000 times that, and enter, and this will be the present value. So according to the calculation here, we're going to say the present value is 240,083, even though they're going to get 560,000 over that 14-year time period. Let's kind of break this down now. This is really useful to do, to break this down and think about it not as an annuity calculation, but as a present value of 1, meaning 14 different present value of 1 calculations. This is useful, especially when you get to more complex cash flow situations where we can use some combination of an annuity calculation if we have standardized payments, and when we don't, we can use the present value of 1. It's also something that's easy to do using Excel, even though no one knows how to do it really, because they just use a magic kind of formula to figure it. But if you look at it this way, it actually gives you a lot more insight into what's going on here. So what I'm going to do is I'm going to say this is going to be 1, 2, and then we'll use the good old autofill. I'm going to select those two, and then Excel guesses that like the pattern's going to be 3, 4, 5, 6, which they're right. Home tab, alignment, center that one. Then I'm going to say that the payments are going to be this 40,000 again. And then I'm going to present value each one of them. So that first 40,000, I'm going to bring it back to the current day. So I'm going to imagine it's a year out, and we're going to bring it out to year 0 at this point. So I'm going to say this is the 40,000. I'm sorry. One more time. Let's do this. This equals the present value. So it's a present value calculation now. And we could use a present value formula. We're going to use the Excel to do this present value. It's going to be the rate is going to be the 14%, comma, number of periods is just 1 because we're at the first period, even though there's going to be 14 of them in the full annuity. But we're going to take each payment back one at a time. And then comma. Then we have the payment, which is going to be the 40, actually no payment, because this is the present value of 1, the future value is going to be the 40,000. So we took the annuity calculation and broke it down to a present value of 1, at least for the first payment. So that's going to be that. Let's flip the sign to make it a positive number by putting a negative sign in front of the P. And there we have it. So I'm just going to say that's the value. Now the next one is going to be another 40,000, 2 years out, 2 periods out. Same present value calculation, except now we have 2 periods out when I want to do present value of 1 calculation. So it's going to be equal to the present value, selecting the present value, the rate 14%, comma, number of periods now 2, because we're 2 periods out, and then comma, comma, because this is not going to be an annuity, so we're skipping the payment, going to the future value, which will be that 40,000 that we're pulling back 2 years. I'm also going to put a negative before the P, flipping the sign, and there we have it. So clearly the 40,000 that we're going to get 2 years out is worth less in present value dollars than the 40,000 that we got 1 year out. And if I add those two up, then the present value at this time is the 65,866. So we'll do this 1 or 2 more times, and you can see the pattern that we have here. And we should, at the end of this, get to the same result as we break down the annuity formula into the present value of 1 for 14 different segments. So we're going to say this is going to be equal to the present value, the PV. Let's do it this way. Then I'm going to say negative PV calculation. The rate is going to be the 14%. I'll pick it up there this time, comma. Number of periods is going to be 3 now, comma, and then 0, because this is not an annuity, comma, future value 40. And then there we have it again. If we add this up, it's going to be the prior amount plus what we did this time. There we have it one more time, and then we'll try to copy it down. There's the 40,000. Negative PV brackets rate 14%, comma, number of periods 4, comma, comma, future value 40, and enter. There we have that. Prior it was this, plus we got the 23,683. Let's try to copy this down now. I'm going to try to copy it down and it's not going to work because there's going to be a problem, but I'll just test it. Selecting these three, I'm going to copy it down, see if it does what we want it to do. This one looks right. This one does not look right. Why? Because the rate moved down. I don't want that to move down. I need an absolute reference there. So I'm going to say, all right, let's delete that. And then fix this one, double clicking on it to absolute referencize it something. So on B4, what's B4? That's the cell. It's for the B's for the cell. And I'm going to push F4 there. So now we have a $sign before the B, $sign before the 4. So that makes it an absolute reference telling Excel don't move it down. We only need a mixed reference right there, but an absolute reference will work and it won't confuse me as much to try to figure out the mixed reference, which would only need $1 sign. Now we can select those items and we can do the autofill, dragging it down. And do we get to the same ending point number? I believe we do. Let's add some decimals here just to be a little bit more exact. Home tab, number, decimalize it. And then home tab here, numbers, decimalize. So perfect. It's perfect. It worked perfectly. Let's do it again. Now we'll use Excel's annuity calculation. Now we're going to do it the same kind of calculation, but in a new one calculation for an annuity equals the present value. Still a present value. Looks much the same as what we did over here. The rate's going to be the same calculation, so it's still 14, comma, but the number of periods now is going to be the 14 periods because we're talking annuity this time. We're not bringing back each individual one, comma, and then the payment is now going to be the 40,000 because it is an annuity payment, and we're not going to do the future value because it is this time an annuity, not a present value of 1. And we can also put a negative before the P, so we can flip the sign to make it a positive number. There it is again, 240, 082, 86, done again in like another way. And then let's use the tables. Tables are going to be the 40,000 table time. Now it's the table time. So let's go back to the left and look up the table. So we got the 14%, 1414, 1414. So 14% down below, we've got 14 here. So that's going to be 6.0021, 6.0021, 6.0021, 6.0021. And then let's add some decimals. Home tab, numbers, decimalized. And then home tab, font, underline. And then multiplication, 40,000 times that amount. There we have it. Let's add some decimals. Home tab, numbers, add a couple decimals. So slightly different due to the rounding of the 4 digits on the table time function. If we see what we think it should be, I believe it should be this amount here, this 6.002071, and it was rounded out to 6.0021, resulting in a slight variant in the application. So note again, it's useful to see the difference between this present value calculation, the present value of 1 calculations, and once again, if you get into more complex scenarios and you're saying, well, what if I get like 40,000 for the first year and then I don't get anything and then I get like 100,000 in year 5 or something like that? Well, then this type of calculation is still quite viable in Excel and not even that difficult because we can put a table and use the present value of 1 calculations and then use the annuity calculations when it would be more efficient to do so. So we'll see some problems like that in the future.